In lesson 5.2, we are looking at functions that are one-to-one, and eventually we'll start talking about inverse functions. So here is a definition of a one-to-one function. A function that is one-to-one is when any two different inputs in the domain correspond to two different outputs in the range. All right, so really what that means is for every x value, you have to have a different y value. And if we look at our definition of just a function, if I just do a quick diagram here, we could have every x value going to the same y value, and this would be a function, but it's not one-to-one. One-to-one. All right, so we can see in this case, every x value is going to a different y value. And that's what this means. Every x value gets a unique, I like that word, unique y value. Okay, so unique means different. So every x value has a different y value. So in this example here, in example A, it says to determine whether the following functions are one-to-one. So remember, they already tell us it's a function, so every x value is different, -2, -1, 0, 1, and 2. Now we have to check the y values, and we're looking for all different y values. So we have 6, 3, 2, 5, 8, and none of those y values repeat, so this is one-to-one. Same thing here when I'm looking at this list of states and it's corresponding to the population in this state. Every state is different, every population has a different value, and every state is matched to a unique population value. So this is also one-to-one. And that's because every x goes to a different y. So another way we can look at one-to-one functions, if we look at a graph, we could use what's called the horizontal line test, just like we had a vertical line test to determine if we had a function. The horizontal line test will determine if our function is one-to-one. All right, so if I draw a graph of x squared, so we've done this 1,000 times or more, and if I draw a horizontal line, notice how a horizontal line touches in two places. This shows that x squared is not one-to-one. Okay. Then if I look at x cubed, okay, our familiar chair function, and if I were to draw a horizontal line anywhere through this, it's only touching in one spot. So I can see that x cubed is one-to-one. And in general, if I look at this, this is an even function. Even functions are not one-to-one. Whoa, sorry about that. Even functions are not one-to-one. And x to the third power is an odd function. And we can say in general, x to the third or odd functions are one-to-one. All right. Remember, even functions are reflective over the x-axis, so I've got a point on, or over the y-axis, so I've got a point on both sides of the y-axis in which the horizontal line test won't work. Now looking at this next part, we have the definition of an inverse function. All right, so an inverse function is basically two functions where one function undoes the other function. All right, so it says suppose f is a one-to-one function, then for each x in the domain of f, there's exactly one y in the range. So here's the domain and here's the range. It says if, or the correspondence from the range of f back to the domain of f is called inverse functions. So basically, if I look at this map here, I pick a number for the domain of f, and I go over here, and the output is the range. Now to get back here, this becomes my domain, and I'm plugging it into something to get back to where I started, which becomes the range. All right, so basically what this means is the domain of a function will become the range of the inverse, and the range of the function will become the domain of the inverse. And you notice here I see f to the negative first power. Actually, here we're going to say f negative 1 represents the inverse function. It's not a negative 1 exponent. It just indicates inverse function. Okay, and so that's the inverse of the f function. So in example 3, it says to find the domain of the inverse function for the given function. So this is my domain of f, and this would be my range of f. Now this in my inverse function becomes the domain of the inverse function, and this now becomes the range of the inverse function. So it says to find the domain of the inverse function. The domain of the inverse function are this set of numbers. So I can say that the domain, or I can say the inverse function domain is, and I'm going to make a set, 6.2, 6.1, 0.8, 8.3, and 5.8. Okay, so this becomes the domain of the inverse, and it doesn't ask, but we're going to state the range of the inverse, and it's just a list of all these states. So I have Indiana, and I'm just using abbreviations, Washington, South Dakota, North Carolina, and Tennessee. All right, so domain and range. So now we are looking at the inverse of this one-to-one function. So it tells us it's one-to-one. So all the x's go to different values and all the y's go to different values. To find the inverse of this function, all we have to do is switch the x and y values. All right, so if I were to rewrite this function as the inverse function, I'm going to have the set of points 27, negative 3, so I'm just switching these around, negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, those were easy. Then I have 8, 2, and 27, 3. So I just switched the x and y values for that. So then we have the definition of an inverse function for x. The inverse of the function, the f function, f of x, is written as, and we were doing this above, f negative 1 of x, and it undoes the original function. Okay, so, and we did this a little bit back in section 5.1 where we showed the composition of two functions that gave us x, and really that's what this is we have two functions where the composition of them get us back to just a plain x. So here's an example. If my function is 6x and my inverse function is 1/6 of x, because I know if I multiply a function by, or a value by 6, I then multiply it by 1/6, I'm going to get back to x. And to just show that, I have f of g of x, and that's going to be, or f of f prime of x. I didn't label that of g of x. F prime of x is 1/6 x. And I multiply that, I'm plugging that into the f function, which is just 6. So the 6 times the 1/6 would cancel, and I just get x. And I also go back the other way. So I have f inverse of f of x. That means I'm going to take f of x, which is 6x, and I'm going to multiply that by 1/6, or I should put that over here, 1/6 times x, but anyway, I get 1/6 x. All right, so this is just kind of like the generic form of how that's supposed to work, and here's just a real quick and easy example for that. All right, so on the next side, almost done here. Here we have that g of x is x to the third, and the inverse is the cube root of x. So I am going to find g of g prime inverse of x and show that that equals x. So if I do that, I'm going to take the inverse of x, which is the cube root of x, and I'm going to plug that into x to the third power. So I know that the cube root of x is x to the 1/3 power, and if I multiply that by 3, which is my exponents, I multiply my exponents, I just get x. Then I'm going to take the inverse of g and find the composition of that and g of x. So I'm going to take g of x and show that that's equal to x. So I'm going to take g of x, which is x to the third power, and I'm going to plug this into the inverse function. So I'm going to take this and plug it into the cube root function. So here I have, again, the cube root will undo a cubed, so this goes back to x. Last example for today is we're verifying that the inverse of f of x is, we're verifying that the function and its inverse are equal to x. So let's first show that f of f prime of x equals x. And it also says to show any restrictions on the domain. We'll do that in a second. Then I need to show that f prime of f of x also equals x. So f prime of x is over here. So I'm going to do f of 1 over x plus 1. Now I am going to put this into this function. So I have 1 over, and then x is 1 over x plus 1, and then I'm going to add 1 to that. So this right here is my f function that I plugged in for x, which is right here. So now if I simplify this on the denominator, I have a +1 and a -1. This is a -1 right here, sorry, from this. So I can cancel these. +1 -1 goes away. So I have 1 over x. So I really am multiplying by the reciprocal here. This is 1 divided by 1 over x. So if I multiply by the reciprocal, this becomes x. All right? And in the domain, I see that x cannot equal 0. So x cannot equal 0 here. Now in this function, I'm going to take f of x, which is 1 over x minus 1, and plug that into the inverse function. So now I have 1 over x, and I'm putting in what x equals, 1 over x minus 1, and then I have plus 1 right here. So now I'm going to kind of simplify this here, and I'm going to, again, divide by 1 over x minus 1, so that means multiply by the reciprocal. So I'm going to flip this over, so I have x minus 1 here, and then I'm going to add 1. So this also becomes x. And I know here that x cannot equal 1. All right. So that is just showing that a function and the inverse, those operations undo each other, and we'll get back to x. All right, we're going to spend some time on graphing the inverse functions in the next lesson.